I'm John from Unix Surplus, and today we're going to take a look at AMD EPYC CPUs. We're going to go everything from Rome, Milan, Genoa, and Turin over here. We're going to go over all the details about how you can build a cool server using available CPUs that might be at discount, what the different part numbers mean, how you can get a good deal on them, and how you can make this really help you out to get some money building a really cool server rig, a desktop rig, how it all applies and what we make it happen, okay? So let's come on by and take a look at some details about EPYC CPUs. So let's talk a little bit about code names and binning. So they're all named after Italian cities, with some of which I've visited, that all have great Italian food. Most electrical engineers like me like to have a cool code name that makes you happy when you're working late at night and dealing with deadlines. So where did it start? It started out with Naples, which was Napoli, which is the 7001 series. Very old here. This went up to 32 cores and only supported PCIe 3.0. Then you got into Rome, which was the big one because you got PCIe 4, which was much faster linking between the CPUs, and you got up to 64 cores. A lot of people are going to end up in Rome because of the value. Okay. Then you go into Milan, and this is all SP3 with these size sockets. You can see them over here. Milan had new code in it for compression, and that's anything ending in a 3. So this is a 7713. There's 70003. Anything 4-digit ending in 3 is Milan. Okay. These are going to be a little bit more tricky for you to work with finding motherboards, because not every motherboard might have the right configuration to do that. We'll go over that. Okay. Then we move into socket SP5, and you can see between SP3 and SP5, this is really just like two SP3s put together. Yes, they made a new die. These are going from 4-core sections, so they're multiples of 4, to 8-core sections. So if the 64, you're going to have 8, 8, 8, 8, 8, 8, 8. All the way around. So these are 8-core units that are share cache between 8. These are now going up to 500 watts. They're a much bigger thing, and we'll take a look at what about that too. But you're going over to Milan. These are Genoas and Turins. Turin is the newer stuff that just came out in 2026, and that is socket SP5. We can take a look at some of the holders and spreaders. These are useful for putting it in so you don't damage your socket. My general feeling is that if you have a 7002, it comes in green. If you have a 7003, it comes in gray. If you buy it from HP or Dell, typically these frames, carrier frames here from AMD, are blue, which are like the OEM frames. I don't know. Comment down below if you have any comments about how the frames influence each of these different CPUs. So we talked a little bit about the CPUs. We talked again, SP3, SP5, all the different code names that matter. Rome, Milan, Turin, all these things come on up. Okay, now let's talk a little bit about binning and what binning is in terms of a CPU card. So I don't have much time to plug this into a socket and test it at the factory. What they do before it even gets on this chip is they're going to make a bunch of chips, and they're going to hook it up for power. If this system, and it was a good wafer at like 1.3 volts, consumes so much power, they know from statistics that they're going to have generally a good chip that'll support like the high cores, and its 64 core won't get much power. So if you're buying a 16-core high-speed CPU, they might bin it or test for power, that it's going to run at higher voltages well, and how much power and heat does it do at those temperatures. All this is done when you still have a semiconductor wafer. So they kind of take a look at it, see how the wafer batch came on out, and then they're going to decide what CPU it'll be best for in packaging in that. Oftentimes, between the different CPUs, they have the different resistors on the bottom, and that's what those do. Those are solderable on the bottom of the chip, so you can add those in there and configure it from the factory. All of the EPYC series CPUs that we're really looking at here for server builds that we're interested in are pretty much the same die package, and we can't see it. Other package SKUs, we talked about binning. That's measuring power and then seeing what it's going to be later. Big topic within CPUs for overclockers. They want to get the best power for it or whatever they want. Typically, anything that says EPYC on it versus Threadripper is going to be locked up. You're not going to do very well with an EPYC CPU and trying to go ahead and overclock it. The last thing you need to talk about is notching. These are the different control notches that mean what fits in the socket. You'll see that Threadripper and Epic will have different notches on them as well. We can go over that type of stuff too. Sometimes people do that so that they can use the same socket and hardware. They just change the pinout and the notching for different electrical pinouts. Most all of these Epic families have in SP3 are electronically compatible. The only difference in these is the firmware on the board and whether your board supports the firmware. So we talked a little bit about binning, what the CPUs are, notching, and a lot of details here. So now let's talk a little bit about the part numbers and how they apply and little details you might have missed. It's pretty obvious that the last digit between being a 1, 2, 3, 4, 5 is the generation of the CPU. So we're going to start out with Naples ending in 1. We're going to move on to Rome at 2, move Milan at 3. We're going to move on to Genoa, ends in 4. Turin ends in 5. Talking SP3 family, you had 3 generations. SP5 family, you have 2 generations. They're looking at changing the socket because they need to get the liquid cooling after 2 generations of CPUs. So that's the last digit of the part number, either ending in 2, 3, 4. We can take a look at that. So that's the part number thing. The other factor of the part number is if you have an OEM CPU or a retail CPU. Okay, so OEM CPUs are made for like Facebook, Amazon, and that. And they don't want those people selling them to anybody else. One here's an OEM CPU for Facebook or Amazon. It has a character in it. It's a 7B12. This is a 64-core CPU here. And if you take a look at any other distribution CPU, it looks the same. This is a 7262. Very similar, same family. This is going to look identical, but because they changed a letter in it, they know that they've made that for Microsoft. They've made that for Amazon. They've made processors for that. Typically, if you have a letter in the socket, it's going to be max watt for that socket. They're not going to save on wattage or anything like that. What you can't tell in the part number when you have a B is if it's single or dual CPU socket. And that's where it comes in the last letter. If you were to have a P at the end of the CPU, that's single CPU socket. That determines how many PCIe lanes. If I'm having 2 CPUs, they're talking to each other and they need to communicate to share memory. So half of my peripheral I/O goes to the other CPU. So this is a system on a chip design, and it was very innovative. And they said, we're going to use the same thing we talked to all your networking cards with PCIe to talk in between CPUs. Maybe not the fastest. Everybody hates it in the electrical engineering community, but hey, it works. That allows them to have a P CPU have 128 lanes out to peripherals. So if you want to hook up a lot of NVMe drives, you want to hook up a lot of PCIe cards, you want to do that, you need a lot of these PCI lanes. X16 bus, 16 lanes. If you have a dual CPU system, you're only going to support 64. You're only going to get 2 X16 slots, 1 drive, and maybe the rest of your peripherals. If you get a P CPU or a Threadripper, that'll have 128 lanes out. So back to the part numbers. If it ends in P, it's single socket only. More PCIe lanes, supports more NVMe lanes in the server. So now let's talk a little bit about the part numbers and how they apply and little details you might have missed. It's pretty obvious that the last digit between being a 1, 2, 3, 4, 5 is the generation of the CPU. So we're going to start out with Naples ending in 1. We're going to move on to Rome at 2. Move Milan at 3. We're going to move on to Genoa, ends in 4. Turin ends in 5. Talking SP3 family, you had 3 generations. SP5 family, you have 2 generations. They're looking at changing the socket because they need to get the liquid cooling after 2 generations of CPUs. So that's the last digit of the part number, either ending in 2, 3, 4. We can take a look at that. So that's the part number thing. The other factor of the part number is if you have an OEM CPU or a retail CPU. Okay, so OEM CPUs are made for like Facebook, Amazon, and that. And they don't want those people selling them to anybody else. One here's an OEM CPU for Facebook or Amazon. It has a character in it. It's a 7B12. This is a 64-core CPU here. And if you take a look at any other distribution CPU, it looks the same. This is a 7262. Very similar, same family. This is going to look identical, but because they changed a letter in it, they know that they've made that for Microsoft. They've made that for Amazon. They've made processors for that. Typically, if you have a letter in the socket, it's going to be max watt for that socket. They're not going to save on wattage or anything like that. What you can't tell in the part number when you have a B is if it's single or dual CPU socket. And that's where it comes into the last letter. If you were to have a P at the end of the CPU, that's single CPU socket. That determines how many PCIe lanes. If I'm having two CPUs, they're talking to each other and they need to communicate to share memory. So half of my peripheral I/O goes to the other CPU. So this is a system on a chip design, and it was very innovative. And they said, we're going to use the same thing we talk to all your networking cards with PCIe to talk in between CPUs. Maybe not the fastest. Everybody hates it in the electrical engineering community, but hey, it works. That allows them to have a P CPU have 128 lanes out to peripherals. So if you want to hook up a lot of NVMe drives, you want to hook up a lot of PCIe cards, you want to do that, you need a lot of these PCI lanes. X16 bus, 16 lanes. If you have a dual CPU system, you're only going to support 64. You're only going to get 2 X16 slots, 1 drive, and maybe the rest of your peripherals. If you get a P CPU or a Threadripper, that'll have 128 lanes out. So back to the part numbers. If it ends in P, it's single socket only. More PCIe lanes, supports more NVMe lanes in the server. Last thing about looking at CPUs is scratches. This CPU has scratches on it. And what does that mean? Absolutely nothing. It's going to work the same for you. However, if I'm a person trying to resell this CPU back to Supermicro, I'm not going to be able to because it has some goo and scratches on it. It's used. I need to have a pristine, brand new looking CPU. So no scratches in the market. That's just sold to people that want to go and turn it back into some person that needs those CPUs. And they have to remarket it as new. Okay? Scratches are your friend. They're great. Scratches on the bottom, that's a different story. Every CPU will have a little bit of goo that always travels through it. Okay? Whenever you're handling CPUs, they come with goo. The goo is young on a 7003, on a 7001. Goo is old and dry. You can clean these up with alcohol. If you do have a bad pin or something that has corrosion, it might be a power data pin. Not all your memory banks might work. Do take a look at the CPUs, clean them well with alcohol in an anti-static environment, and then we can go ahead and make sure that you have a good CPU based on clean pins here. Scratches top, doesn't matter, go for it. You're going to save some money because they can't resell that CPU as new. So let's talk about the difference in socket. Right now, you're going to find some 64-core CPUs in a 7002. Maybe a good deal on an engineering sample. You're going to get it for $300. Right now, we're selling this one here with a B in the part number from an Amazon. We're selling that at $299 on eBay, $300. If you go into Milan's, you're probably going to be paying at that same 64-core in a good part number, $800. Turin. If you want to get into socket SP5, you're going to be paying more per CPU. You're talking here 1,000, 64-core, 128s. You might get an engineering sample 128 for 1,000. You're going to be paying $1,500 for 128. So if your class is, I'm trying to build a server and I'm looking for it, your base cost is going to be maybe around $500 for a motherboard here in P3. You'll be lucky to find a single core board here for $500 in SP5, a dual core motherboard. Good luck. You're going to be paying $3,000, $4,000 a system. So what class are you looking at? You need to understand where you're going to go. Typically, everybody here is pretty happy with Rome. They don't need the features. They need to do that. People that want to do compression or other stuff, I believe you get into AVX extensions here. This is some of the AVX extensions were put into Milan and Threadripper when you got into Zen 3. When you want to go into Zen 4, you get AVX 512, which is really important for AI and compression and large matrices, working back and forth with that. You also get other instructions for security and floating point. So this is bfloat 16 as well instructions, which is 16-digit floats. So that helps again in doing some of your floating point operations that you might want to be offloaded to. So There's a little bit of and if you want to talk about instruction sets, if you want to do some very particular application like video compression, ray tracing, some form of rendering, those things, that rendering needs a lot of B floats. You need to get up in the latest CPU. We work a little bit with Lucasfilm and we see what they do. We see what they buy. We get their surplus stuff there. They're right now worked a deal where they got rid of all of their Rome 7002 in Milans, and they worked an upgrade to get into DDR5 technology Genoa CPUs because they wanted to get the latest floating point so that their ray tracing on their workstations was much faster. What's the last consideration on the socket is memory. And memory is a big problem right now here in 2026 because it's gone crazy. You're talking DDR4 memory, you're talking DDR5 memory. The speed of your memory is also important. ROMs will work with 2400 speed memory in DDR4. You're talking about $10 a gigabyte, maybe $7 if you're lucky. Milans, they need 2933 speed. You're going to have to buy higher quality, higher speed memory to run your Milans at the higher speed memory bus. And this is DDR4. Your big jump comes into working with Genoa, and that's DDR5. Again, you get much faster performance out of your memory bus. It's good, but you pay for it. You're talking $25 a gig here, $10 a gig here, maybe $15 a gigabyte here. So you can see the progression. We're hoping that the end of 2027, you're going to go back down to $5 a gig for 2400 speed. You'll probably be seeing this at around $6, $7 a gig for 3200 speed. And then this thing we'll see back at around $15 to $20 a gig by the end of the year. Manufacturers aren't predicting that because they said they're all out there, but you'll be able to find used memory that's an older part number for those prices. So that's the differences that you're seeing in price about how you're selecting your socket. So what's best for you? You're probably going to be if you're an economy builder looking at ROMs, you're going to be looking at a 64 core or a 32 core if you're running VMs. And then you're going to want to look at your clock speed. You're looking at a 16 core if you're a gamer with a high clock speed, and you're taking a look at ROM. You're going to get some economy memory. Maybe you get faster memory. It's up to you. Things like the 7713. This is what you're going to be if you're a little bit more of a pro. You get a good deal on it. You know that your motherboard supports it. You're going to be there. This is where most of the system builders are with DDR4 technology. If you're a company, you got $10,000 to spend, sure, get into Genoa. Get into DDR5 memory. And that's your choice. Let's talk about power. Power is TPD, total power distribution. When you put more power, you can drive your memory faster. Obviously, all these pins here need to talk to all those signals on your memory bus and drive it a little bit faster. What else do you get with power? You can have more cores. Obviously, you got so many CPUs running, you got more power. Or you also have frequency or clock speed. The higher voltage you run, the more faster you can bing bang your transistors inside, and goes there, you get more power. What you're going to see is that lower cores support higher clock speeds up in the 4.5 and that. What is the EPYC line designed for? It's designed to run reliably in data centers and run consistent under heavy loads. We start out here with, again, our 7501, which is a 32-core PCIe 3.0. You can see here it's 0.47 pounds. This here was built out. It's got a big copper heat spreader. This thing here only went in, I believe, at 180 watts. So it didn't support all the cores. What was that tied to? That's tied to the voltage regulators on your motherboard, how much heat it does, and how much memory it can do. Quickly, they came out with 7002 ROM. That supports up to 240 watts. You can see still it's the same package. They knew it was coming. 0.47. It's got the same amount of copper in it. This is anything ending in a 2. 7002, supports up to 240 watts, goes up to 64 cores. You're only going to see these come in, even in the smaller cores, around 3 gigahertz. Designed to be reliable, lower total power. Okay, what do they need? They need to come out with new cores, new instructions, and everything else. They're coming out with 7003. 7003, what do we get? 0.49. A little bit more copper in there. Supports more power, a little bit better, 280 watts. What are you doing there? How much it is. How much copper spreads out that heat, allows you to run those a little bit faster. It comes up with a new refresh. Obviously, a new die shrink from TSMC. What does it go in then? You want to go in 500 watt SP5s. What are you at? 5.2. This is huge. This is a big, heavy CPU. What is that? 4.6, you're at 9.6. Almost half of, it's still a little bit over half of each of these CPUs what you have here. What is this allowing you to do in total power? This socket can go up to 500 watts if it's liquid cooled. You're going to have a problem at 500 watts because not only the heat comes up the top, the heat goes down the bottom and into the pins of the motherboard. What is that required to dissipate that amount of power and everything else? You need a motherboard that's really, really, really heavy. This here is a workstation board right here based on Threadripper. This thing has all this copper on the bottom. What's that doing? That's taking the heat out here, distributing it back up into these heat sinks there. This whole thing here, 6-pound board. PCB board in here should have been about half a pound. This has got 5.5 pounds of metal just in cooling around here. So this is again an Asus X80E. This is the Sage boards. This is used for the Threadrippers. Same socket you can see here, SP3. Gonna have different notching. Going to perform differently, only designed for Threadrippers for workstations. So we talked a little bit about power, how weight influences it, and how the copper spreaders goes. You got power coming up the top, you got power going down the bottom. Why do they need a new socket? Well, they're going up to 1400 watts liquid cooled. They got to make sure nothing melts. Where are your voltage regulators that drive that amount of power? They're right here, underneath all of your heat sinks on this board. The size of that is dependent on the components. The 32 cores and the 7511s have smaller original releases, have very small voltage regulators. If you need to support something between a board, between the 7002 and 7003, you got to make sure you have enough voltage regulators to do that for the higher wattage. That's what cleans your power, drives the CPU. CPU asks for more power, less power. That's your voltage regulator does that. So VRMs, we talked about power and a little bit about the difference in the boards and how it influences the sockets. And you even saw a little bit of difference in weight, how the faster, newer CPUs need more copper in them and they're heavier to support that. So what's your choice going to be here? Well, maybe you can go with a ROM and get a good deal because you get an OEM part number. What do you think about that, Coco? With a B in it, she likes that one. Or maybe you want to be an Intel guy and you like Intels and these are nice because they support that. Looks pretty sexy. Maybe she looks away from Intel. Oh, that's not her choice. Maybe she's really high price and that she likes Genoa and that. Oh, yes, that's definitely her choice. She's a DDR5 puppy. What's going to be your choice? Ask us. You need some comments? We're here watching our videos and our sales team's ready to help you. Like our videos, subscribe. I know it's been a little bit long, but we got a lot of information here. Thanks for watching. I hope you enjoyed it. Oh, I think Coco chooses her daddy.